Okay, I think maybe now the audio is working. Anyone in the chat, can you confirm at this point that audio is working? Thank you, Laura. Hi, Laura. It's good to see you on the live stream. Are you guys, you're out in Arizona, right? So you probably have a really great view, New Mexico area. Will this be visible in South Florida? Yes, I believe it will be. I think the entire United States will be able to observe this eclipse. So because we didn't have any audio up until now, you guys missed out on some really great discussions. I noticed that some people were commenting that it's really great that it's quiet. And I can totally appreciate that. I mean, there's nothing like having a nice view of the eclipse up on your screen and not having to listen to a bunch of geeks talking about it. So if that's the case, by all means, please just turn on your volume, mute the video. We definitely will not be offended by that. We are all about that, to tell you the truth. But for those who want to listen to a little bit of commentary, we will periodically be discussing the eclipse. And we'll be talking about what the eclipse is, what we're seeing, the different stages we're in. You'll hear us talking a little bit about what we're doing. So I'm going to boot Derek's view real fast, and I'm going to do a quick share of mine real fast. All right. So I currently have my camera is set up in archive mode. And this here is a view of that eclipse from that camera. Now, you can see very clearly right now that one side of the moon is starting to get that bite, that chunk taken out of it. And that's because we have now switched over to the next stage of this eclipse. The eclipse started at 9:32, and that was the penumbral part of the eclipse, the penumbral eclipse, which is when the moon starts entering the secondary shadow that Earth creates from sunlight as it blocks sunlight. The primary shadow, called the Umbra, which is where no sunlight directly from the sun will reach the moon, is what the moon has now started to enter. This began at 10:28. And at this point, we're starting to notice that a large chunk of the moon is now becoming dark. And this is going to progress pretty quickly. And this is the moon moving into the primary shadow of Earth. Now, when you think about Earth shadows, you can do this with your cup. So say you're at work and you get your coffee cup on your desk and you have a bright light behind you. You'll notice that on the opposite side of your cup from the light, you'll see the cup's shadow. But if you look to the left and the right of the shadow, you'll notice that there's another shadow there too. It's not as bright. Sometimes it's very, very hard to see, but it's almost like a dim version of the shadow. And that's the secondary shadow. What's happening is some of the light's making it there, but not all of it. the cup is blocking some of it, where directly behind the cup, there is no direct light reaching that area. You're just getting lights bouncing off of other parts of the room that's illuminating it. And that happens with the moon as well. So Earth's shadow, which will be on the opposite side of Earth than the sun, will have a secondary shadow as well. And that secondary shadow is what you're going to see during the penumbral eclipse. Penumbral eclipse is visible, but it's just a dimming of one side of the moon because most of the moon is still in direct sunlight. Once the moon starts to enter the umbra itself, we end up with part of the moon now in full shadow. And as this continues to progress, the moon is going to become dimmer and dimmer, and you're going to see less and less of the moon. Eventually, what will happen is the moon will enter the full umbra of Earth, or the Earth's primary shadow, and that's going to happen at 11:29 p.m. At that time is when the moon is going to really take on that red color, that crimson red or that blood red. And you hear the term all the time, the blood moon or the crimson moon or the red moon. And this comes down to a process called, two different processes. One's called Rayleigh scattering and one's called Mie scattering. Rayleigh scattering happens when the visible spectrum of light, you're talking red on the low energy side, which is where you got a pretty wide gap between those wavelengths, green in the middle, and then blue on the high energy side, where you got a very small gap between the wavelengths of light. That's broad spectrum light. That's the visible spectrum. When broad spectrum light from the sun comes into Earth's atmosphere, the blue side starts to encounter a lot of the just air molecules, like oxygen molecules and nitrogen atoms and all this stuff. And not all of it can fit between the blue wavelengths, and it causes the blue light to scatter and become polarized and stay in the atmosphere. This is why the sky is blue during the day. It's also why you get that kind of orange moon on the horizon, or when the sun gets kind of orange when it's really low on the horizon, because you're looking through a lot more atmosphere at that point. Now, Mie scattering is when larger particles get into the atmosphere. Particles like ash from a volcano, or ash and smoke from a wildfire, or smog from industrial pollution, or from the exhaust on your car. All of this stuff puts much larger particulates into the atmosphere. And they start to scatter the green part of the spectrum. Depending on how much of that is in the air, you could scatter all the way into some of the crossover between red and green. And if you think about it from a perspective of the United States, up in New England, August is wildfire season. We don't get wildfires in New England, but we do get the smoke from them. And during August, the moon is often very, very red in the night sky, or very, very orange, and that's because of Mie scattering. So when the moon gets into Earth's umbra, it turns red because no direct sunlight is going towards the moon. Sunlight is coming into the daytime side of Earth. It bends, refracts when it comes into the Earth's atmosphere. It'll move through Earth's atmosphere. Some of it will diffract, which bends around the Earth, and then will leave the atmosphere on the other side and refract again, directing it towards the moon. And all that light that is now shining on the moon had to pass through Earth's atmosphere. And in doing so, all the blue light, and depending on the condition of Earth's atmosphere, could be even all the green light, was filtered out, and only the red light makes it to the moon. And that's why you get that deep crimson, blood, red color to the moon. Mie scattering will make the difference between a rather ruddy brown or that really deep crimson red. Stranger 20, are we a little too loud? Yeah, we're going to turn that down.
All right, I'm back. I charged up a little bit. So I fixed my camera view too, so now my view matches the orientation of Scott's, which is accurate to what you would see in the sky if you looked up there. So if we switch back and forth, it'll be less jarring now. But yeah, the next phase of the eclipse is certainly underway.
Those in the live stream, we've adjusted the volume a little bit on our microphones. Is this better? Yeah, unfortunately, it's allergy season here in New England. And no matter how hard we try, it finds its way in. So I apologize for all the allergies you're going to hear on the live stream tonight.
Just blame it on the dome.
Well, it kind of is, because you get this wind tunnel that comes through here. So anything that's in the dome gets kicked up.
Yeah. So when was the last eclipse? Was it 2019?
That's the last one that we had a good view of. There was one recently, though. I think it was in November, and James got a really great image of it. We were clouded out in our area, but it wasn't a good one. It was a sunrise eclipse for us.
Oh, yeah, I remember that actually now. Yeah. I know this is the last lunar eclipse that we'll see for a couple of years at least.
We have another one in November.
I thought that was it'll be a moon set one.
Oh, it's not going to be as good as this one, no.
Yeah.
I'm not too sure the times on it. We do have it on our calendar. Let me take a look real fast. But this is the good eclipse for this year. I mean, this is actually, it's quite upsetting that it's going to be cloudy tonight, because this eclipse really is a fantastic eclipse for us in New England. I mean, maximum eclipse happens at 12:11. I mean, that's right at the highest point of the sky. That means that the total part of the eclipse is going to be at the best part of the sky to see it in. And we're in the time of the year where the Milky Way at Frosty Drew at midnight, 1 o'clock in the morning, looks amazing. So we would have that red moon at its highest point in the sky with the Milky Way behind it. It would have been amazing. I'm glad we have a view at all. So this is definitely not me complaining. This is just me putting out a little wishful thinking, right? Yeah, it's going to be the eclipse in November will begin at 3:02 in the morning. Partial begins at 4:09, and then the total eclipse will start at 5:16 a.m. So we'll see some of it, but not all of it. Derek, you want to switch over to your live stream, or are you busy with other stuff?
Yeah, I can switch over.
All right, let's do it. You could just do it, and it will just kick me off.
Yep, There we go. Should be switched. Let me go back to full screen that thing and then give it a little plus plus.
I didn't know you had a 224.
I have 2 of them. One of them is potentially broken.
You know, I have one. I don't think I brought it with me. That would have been a good idea, right? Because I could have put that in the telescope.
I thought that this focal length I would have like an actual whole view of the moon, but apparently I am a little bit too zoomed in. Hold on, let me cut that down a little bit. Those are a little bright. One of these buttons will do that. Oh. Had it on. There it is. Screen.
Is your resolution up really high? Is that why you're getting that zoomed in view?
Oh, maybe. I didn't play with that yet.
Yeah, bring back your thing real quick and see what the resolution could be switched to under your image menu. See what you have in there.
Well, I'm at the biggest one.
That's it, huh? All right, well, that's it.
That's the full chip. Does it change if I go to RAW 8? Nope.
RAW 8 will give you a better data rate. You don't really need
Yeah,
it.
it just ups the data rate. Oh well. I mean, it is advertised to be a planetary camera, and the moon is pushing the definition of planetary. It's a rather large planetary object.
So someone has asked, it's coming from the left. What's wrong? Should come from the right. I'm assuming that they're stating that the eclipse is starting on the left side of the moon and moving towards the right, and they're expecting it to be on the right-hand side of the moon, move towards the left. And actually, that's not true. When you think about objects that orbit other objects in space, like any moon that formed around a planet will orbit in what we call a prograde motion. Prograde motion is when you orbit in a counterclockwise manner. So the moon, though it appears to be moving from the east to the west, because that's how the sky appears to move, and that's due to Earth spinning on its axis, that's called sidereal motion. The moon actually is orbiting Earth prograde. So if you were to watch the moon in the sky and not pay attention to the sidereal motion of the sky, you would notice that the moon is moving very slowly from the west to the east. And every night, the moon will advance that about roughly about 15 degrees, let's say a little over 13 degrees per night, that advancement will happen. So as the moon is orbiting tonight around Earth, it's passing in the Earth's shadow. And since it's orbiting prograde, it's going to start from when you're looking out from Earth and the sun's behind us, it'll start from your right-hand side of your view. So the left-hand side of the moon or the west side of the moon will be the first part to enter Earth's shadow.
Oh, Scott, somebody's trying to join our call.
Yeah, I'm afraid that someone may have sent out the wrong link. I'm trying to figure that out right now.
I wonder if somebody, yeah, oh well, things happen. We're about a third of the way across the moon now. Time for another image. Let's see, how am I doing? All right, I got to mute again and then start the car. So
Cool. Wendy, this live view is not from Frosty Drew. No, Frosty Drew tonight is going to be under a significant amount of fog. It's been for the last week. So what we're doing is we have 3 of our astronomers, so there's only 2 on at the moment, that are set up at locations around southern New England, places where we think we might be able to get a view of the entire eclipse across our different locations individually. So we can give a pretty good view in the live stream context as the night goes on. Derek, I'm going to switch over to my feed real quick, all right? All right, so you can notice now that the moon has definitely moved into pretty good location here from a perspective of partial eclipse. Now the moon is a little bit more than halfway into Earth's shadow right now. And this is allowing for us to be able to kind of see what's happening with the eclipse. Now, a lot of people in the chat have been kind of bringing up the question, and how come it's starting on the left-hand side? Shouldn't it start on the right-hand side? And, it's an interesting point to note when we look at the sky every day and every night, it looks like it's moving from the east to the west. But all the stuff that we see moving in the sky from the east to the west isn't really moving at all. It's just Earth that's moving. It's Earth, we're spinning on our axis. And that spin on our axis is why we see everything move. And that movement is called sidereal rate, or sidereal time for that matter. When it comes to the moon orbits the Earth in a prograde manner. And prograde means that the moon orbits the Earth counterclockwise. But it takes 27.3 days for the moon to complete one full orbit around the Earth. So the moon moves pretty slowly as it would relate to that daily motion we see in the sky from us spinning on our axis. Now, tonight's moon is orbiting about very slowly into Earth's shadow. And since it is orbiting in a prograde manner, it's approaching Earth's shadow from the right-hand side if you were to be looking out of Earth from the nighttime side of Earth. And that means that the west side or the left side of the moon will be the first part to enter the shadow or the umbra. And as it progresses through the eclipse, the moon is going to continue to move from the left into that shadow, and then it's going to start to emerge from the shadow on the left-hand side of the moon as well. If you were to kind of take a look at the moon tonight, especially during the maximum eclipse, we can see some of the stars in the sky. Try to note the constellation that the moon is in, or some of the bright stars that it's near tonight. And then tomorrow night, step outside and take a look at those stars and where the moon is. You'll notice that the moon is advanced about 13 degrees toward the east from where it was tonight. And even though the moon appears to move from the west to the east over the period of the night because of the Earth spinning on its axis, in reality, the moon is actually moving very slowly from the west to the east. Now, for those who have a view of the moon in the sky, and it's not too hazy, you'll notice that the side of the moon that is in the umbra is still slightly visible, and it is slightly reddish in a way. And that's because the part of the moon that is not fully in the umbra yet is getting thinner and thinner, and it's causing the atmosphere of Earth to darken a bit because the moon's not as bright. It's getting dimmer and dimmer as less of it ends up in the umbra. And that side of the moon that is now in the umbra, fully in the shadow, and only receiving sunlight that's passing through Earth's atmosphere, so all the blue and the green has been filtered out, and it's just red, you're starting to be able to see a little bit of that. And as we move further and further through the partial eclipse stage, that'll become more and more visible. And that's because the moon dims down significantly when it's in Earth's shadow. If we were at a spot like Frosty Drew Observatory tonight, during maximum eclipse, when the moon is fully in Earth's Umbra and it's that nice red moon in the sky, you'd be able to see the Milky Way at that time, and it would silhouette the eclipse. It would be a fantastic view. Now, the next big stage of the eclipse is going to be the end of the partial lunar eclipse stage, which is when the partial lunar eclipse stage is what we're in right now, which is when the moon is moving into Earth's primary shadow, and we're slowly losing pieces of the moon in our view. Once we get into, well, right around 1129 is when the rest of the entire moon will enter Earth's umbra. And no more of the moon, no part of the moon will be in direct sunlight anymore. And that's the time when the moon is going to get really, really red to our view. And that's because the only light reaching the moon at that point is light that has moved through Earth's atmosphere via refraction and diffraction, which is bending of light and then light bending around things. And then as it arrives on the moon, all of the blue light has been filtered out due to a process called Rayleigh scattering. It's why the sky is blue. And some of the green light may be filtered out tonight as well, depending on any events happening on Earth. And that's called my scattering. Now, I am definitely starting to really, I believe I'm fogging out in my location right now. I knew fog was going to start coming in at some point tonight. I just wasn't exactly sure when. I was hoping it wouldn't be until more the morning hours, but it is definitely starting to creep in on me.
So Scott, I've tweaked my exposures so that we can see the more of the red part of the moon.
Yeah, let's switch over to you. Are you any fog or clouds?
I've got some thin stuff, but it's so far not a problem. But we'll see. It's definitely something moving in.
Let's jump back over to you real quick. I'm going to stop sharing, and yeah, and I'm going to take a look. I'm going to step outside and take a look too to see what's actually happening.
Okay. So as Scott was talking about with the shadow moving across the moon, I've tweaked the settings on my camera to capture more light, a longer exposure essentially. And now the fully illuminated side of the moon is on the right. It's absolutely, way too bright. But you can see on the left side of the moon where that reddish color is. And the dimming is actually caused by clouds and moisture that are going through my area of the sky right now. We've got some very thin clouds moving through, which were mostly expected, and I was hoping to avoid them for most of the night. But you can kind of watch this shadow creep across the moon with the way the camera is taking this image now. So we'll leave it like this for a little while. See how that goes.
Hey Ken, how's it going? I've been meaning to call you. I'm just wrapping up finals now, so give me like another week and I'll be like quite available. Are you still in the U.S. or did you end up in Italy?
He said Berkeley in the chat, so I assume he's in the U.S.
Yeah, okay, there we go. Right, he's still in California then. Ken was one of our interns that then became a team member, and now he's out doing his graduate work at UC Berkeley. He periodically comes back in the summer, and whenever he comes back, he comes to the observatory, and it's really a great reunion. We have a lot of visitors that like Ken as well. So if Ken comes around this summer, we'll be sure to post it in our newsletter for that week. You leave for Italy on Friday. I'll see if
Definitely not much of the moon left.
See if I can get in touch with you this weekend. Yeah, I mean, we got a really fantastic view of it here. It's just really, really hazy. Like, it's definitely fog. Like, I can see fog almost at the ground level right now outside the observatory. It's starting to look a little eerie. But we still have the view. We'll see what it looks like when it actually goes into the Umbra and actually maximum eclipse begins. Hopefully, I can still see it at that point. If not, the camera might be able to pick it up.
I think I'm getting a cloud right now. The camera, you can see the red side of the moon is completely not red anymore, and the brighter side of the moon has kind of gotten dimmer. Well, now it's coming back. See, I've got a high level cloud rolling through. You can see all that shifting light is just water vapor, well, a cloud moving between me and that moon. Yeah, we'll see how long this lasts. It's looking like a pretty good sized cloud. Hopefully we can get all the way to like the start of totality. That was my goal for the night. If I can get to there, I'm a happy camper.
Yeah, I was hoping that we can get through the total stage and at least try to get to about almost 1 o'clock. Don't know if that's actually going to happen, but it would be nice if it did.
Goals. Life is all about goals.
Well, to be honest with you, though, Derek, at this point, I'm pretty happy with where we're at.
Oh yeah, compared to what it looked like on like Wednesday and Thursday when I was looking at the forecast, I was like, man, I might want to drive to Ohio.
Right. We have this internal team chat that we often use at Frosty Drew just to kind of pass images around, talk about telescopes, things we're working on, team planning. And earlier this week, when we were talking about the live stream event, we were discussing any of available locations to be live streaming within a 10-hour drive radius from where we are, largely in the center of southern New England. And nothing was coming up. And I had posted in the chat that it looks like anything on the eastern side of the U.S. is just going to be a washout. So we are happy that we've got this much going on right now. And as long as the view lasts, we're going to be, really trying to get as much as we can get live and visible here. Yeah. So, Mara, right. Boston was it was on my list. It kind of showed up today as a possible location. I was actually going to hit up Brian. Brian is one of our team members, and see if I could, crash his place, set up the live stream in his garden. He's just south of Boston.
I might be losing my image here.
Give me 1 second. I'm gonna see if I can kind of clean mine up just a little bit. All right, I can switch over. I got something.
All right.
Hang on 1 second. Let me just check something real fast before I do. All right, here we go. You'll notice on an interesting thing to notice right now on mine, just going to bring it up in 1 second, is that my camera has started to pick up some of that really deep red that's starting to become visible in the total eclipse. And you'll notice possibly around the view, they're going to come and go because of the clouds, but stars are starting to become visible as well. And we are in the very last roughly 6 minutes right now of the partial lunar eclipse. From a perspective of visibility in the sky, looking at it naked eye, there's this, it's actually kind of interesting. It's almost a unique view because with the fog being so thick right now, you can't see any of the part of the moon that's actually in the umbra, but there's this little tiny sliver of moon in the sky, super, super thin little sliver. And it's looks really cool. Though I'm not welcoming the fog by any means, it is definitely a unique point of view that I've not had of an eclipse before. As far as my
fog charmer.
Yeah. As far as my view goes, the camera is able to capture through the fog a little bit, but it really depends on how heavy that fog gets on what we're actually going to see on the live stream. So we're going to continue to broadcast as long as we can. I'm going to assume that James's decision to set up at Frosty Drew was as futile as we thought it would be. And he probably right now is just trying to find his way around the roads in Integrate Park, which is probably completely fogged out. I mean, put it this way, the fog from the South Coast is getting up into Providence. So I'm like 45 minutes away from Frosty Drew. He's like, it's probably about a 5-minute walk from the water.
Yeah, and I can't see the moon at all anymore visually.
I have a little sliver I can see. All right, so we have only a couple of minutes left before we switch into the next stage. Now, the next stage of the eclipse is going to be the total eclipse stage. The total eclipse stage is when the entire moon is in the umbra, or the primary shadow of Earth. During that time is when the moon will become very red to our point of view. Now, tonight's total stage is going to be a little bit longer than we typically see a total eclipse last. And that's because the moon is passing through more of Earth's umbra than it commonly does. Sometimes it passes just through the very top edge, or the very bottom edge, and with the center of the umbra being the widest. Tonight's moon is passing closer to the center of the umbra, which is going to give us a much longer total eclipse. It will begin at 11:29, and it will end at 12:54 a.m. That's almost an hour and a half that we get the moon really red. And 12:11 is going to be when the moon is at its closest point to the center of the umbra for this eclipse. Now, the reason the moon turns red, and though we've been saying this a few times tonight, I want to try to keep repeating it because it's a really good topic of discussion. There's nothing magical about it. There's nothing superstitious about it. It's a basic process that we experience on Earth every day. It's a process called Rayleigh scattering, and then a secondary process called Mie scattering. To understand Rayleigh scattering, you have to think about the visible spectrum of light. So when you think about the electromagnetic spectrum, you have radio on the very low energy side on the edge, and then you got gamma all the way up, the gamma rays on the super high energy side. And right in the middle of all of this is a little section that humans can see, and it's comprised of red, green, and blue. The red side is the low energy side, which is where you got a wider gap between those wavelengths of light. Green is in the middle, and then on the high energy side, you have the blue color, blue and violet, and that's where the gaps between those wavelengths of light are really, really thin, really narrow. Now, red, green, and blue light together is broad spectrum, it's white. When that comes into Earth's atmosphere during the day, you'll notice that you won't notice it, but what happens is all of that blue light, with the really thin gaps between the wavelengths, really narrow wavelengths, it encounters just air, oxygen molecules, and water vapor, and nitrogen atoms, and so forth. And some of these particulates of air can't fit between those wavelengths. And when the blue sunlight hits those particles, it scatters and becomes polarized and stays in Earth's atmosphere. This is why the sky is blue during the day. This is what you experience every day with Rayleigh scattering. Now, the secondary component, which is Mie scattering, is when larger things get into the Earth's atmosphere. Things like ash from a volcanic eruption, things like smoke and ash from a wildfire, things like smog from industrial pollution or too many cars on the road idling in traffic. All of this stuff creates much larger particles in the atmosphere, and those particles start to scatter some of the green and even some of the area where green and red start to meet as well. That's why you get that really white, hazy sky on those really like smoggy days or during August when we get all the wildfire smoke. And red light is the only thing that really makes it through. So when you're talking about an eclipse, now you got the moon is in Earth's Umbra, right? You have, which is starting right now, by the way, may I add, it's 11:29, and we are, you can see on the image, we're losing the very edge of the moon. Once it drops in, I'm going to put my exposure up a little bit to see if we can get a little bit better view. So the moon is in the Umbra. No direct sunlight is now going onto the moon. The only light that's going to the moon, or that's shining on the moon, is coming through Earth's atmosphere. So you have three properties of light. You have refraction, which is when it goes through things and bends. You have reflection, which is when it bounces off of things. And then you have diffraction, which is when it bends around things. In this case, you have a little bit of refraction happening when the light comes into Earth's atmosphere. And you have a little bit of diffraction happening as it bends around Earth. And then you have another little bit of refraction happening when it leaves Earth's atmosphere. And that directs the sunlight towards the moon. So as that sunlight comes through the Earth's atmosphere, and then it ends up on the moon. But because it all went through Earth's atmosphere, all of the blue light and a good chunk of the green light, depending on anything that may be going on Earth at the given moment, has stayed in Earth's atmosphere. So it largely filtered all that out. And it's only the red light that makes it towards the moon. And that's what gives you that. Anywhere from a ruddy brown all the way to like that deep crimson red view of the moon. So totality begins at 11:29, Rebecca, and it runs until 12:54 with maximum eclipse on at 12:11 a.m. So, Patricio, yeah, that's a good point, that you can see the round shape of Earth. One of the things we do with all the data that we collect is we'll put together a mosaic of different stages of the eclipse. And when they're put next to each other, you actually can get a view of not only Earth's umbra, but where the moon went through Earth's umbra. We've done this with the 2015 eclipse that was in September and with the 2019 eclipse that was in January. All right, so now the moon is largely in Earth's shadow. You'll notice that the left side is still dimmer than the right side, and that's because it is still moving into Earth's shadow. Now, at my location, I can see it in the sky, but just barely visible through the fog. And on the screen, you can tell it is quite washed out, but it is visible. So I'm going to make a quick adjustment, and then we'll bring it back real fast. And try to see if I can't crank up my exposure just a little bit here. Now, normally at this point too, I take the camera on my drive on my mount, and I switch it to run in sidereal rate instead of lunar rate. And that's really cool because what it does, it gives us a really great image of the moon as it moves against the starscape behind it. We did this in 2019, and it was really an amazing view. But tonight, we're not going to have any background stars because of the fog, so I'm probably not going to bother doing that. So let's see what we can get right here with that adjustment done. So that's a long exposure. Let's crank this up a bit. Now that the moon is so much dimmer, we've ended up having, it's a bit trickier to kind of get our images. Let me see. Bring this back down a little bit here. And then the fog is just really kind of creeping in on us. There we go. Let's give this a try, see what this looks like. Yeah, that should work. Yeah, but we're totally it's gone right now. At the moment, we'll give it a couple minutes to see if we can get it back. But I do believe that we may have lost it periodically, and hopefully no longer than that. All right, I'm gonna reshare this. But there's, like I said, it's a little rough at the moment. Derek might actually have a better image at this point than I do here. Yeah, I mean, you can just barely see the moon. We definitely are pretty fogged out here right now. I'm even looking outside. I mean, I'm starting to have trouble looking across the street. Derek, you want to switch over? Yeah. Let's let Derek take over a little bit. He's got a better view than I do.
We'll see for how long, because I've got clouds that are, you can see now it's getting darker, coming and going. So I've taken 1 second images here, which is an atrociously long time for the moon. but
Yeah.
it's beating the clouds a little bit. The clouds are currently winning. We can see a not as black circle, but we'll see if it comes back anyway in a little bit.
I might have something in a little bit. We'll see. I'm kind of in and out with fog.
Yeah. I lost it visually again, but
This was our concern tonight, was that there was going to be no spot that we were going to find that would probably have a decent view of it at this time, except for maybe south of Boston, but there wasn't too many sources that were saying that. We actually had some weather sources that had the clouds coming in from the south, others coming in from the west and northwest. I felt like this was definitely a tricky one to figure out.
yeah. Definitely. I've got about maybe 20 minutes of battery life on the laptop, so I'll stay in chat for a little bit, but if I disappear suddenly, that's why.
Yeah, you got your new battery pack with you?
I do, but the inverter that's supposed to work with it doesn't want to power on tonight, and I don't know why. So I'm using my old 200 watt cheapo inverter from like my college days that just lives in my car, and well, I don't want to drain the battery in my car and not be able to get home, so I have to run the car when I'm running the inverter, which is tricky for audio since the laptop is currently sitting on the hood of my car.
I'll be right back. I'm gonna take a look outside and look at the neighborhood.
Sounds good. Yeah. Other than that, though, well, we've got a black square with a slightly brighter circle in it. That circle is the moon through a lot of clouds. And the view does get a little better at times, and then the clouds move back in. So you'll get some glimpses here and there. And when the view of the moon does come through, you'll note that it has a pinkish hue to it, or red. And as Scott was explaining earlier, that's due to the diffraction of light through Earth's atmosphere. That changes. The red light has a longer wavelength, so it bends differently than the blue light. And when we see the light here on Earth, we see the blue light versus the red light, except for at sunset and sunrise. Should probably go watch the YouTube stream so I can see the questions. Wow, can't even see the circle anymore. Yeah, of course the clouds come in right as totality starts, right? That's how the world works. So I lost it completely again. Oh, I lost things completely again. Now
Yeah, it's same here too. It's totally fogged out here.
Oh, no good.
I mean, on my view, you get like this ring with a little red in the middle. That red is the moon.
Yep. The circle is the back. But, well, we'll keep things going and see what happens. We've got what? Another 45 minutes of totality. So,
yeah, about that. No, more than that. Oh, between 21, we got about another, about an hour and 10 minutes.
Oh, wow. Really
Yeah,
long.
this is a long eclipse.
Yeah. Takes a while for the moon to move through that whole shadow.
So Marissa, she asked, how often does a lunar eclipse happen? We get roughly 2 lunar eclipses a year. We usually see them around this time of the year, like May. Sometimes you get them in November. Those are pretty common. But occasionally we'll also get them in January. We've had one September area. We have another one happening this year in November. And the last one that occurred, I believe it was possibly in November last year.
Could have been.
Let
And
me
it
take a look.
varies. It varies based on, where the moon is relative to your location, if you're going to see the eclipse or not. So when we say 2 a year, we mean 2 a year somewhere on Earth.
Yeah, with the lunar eclipse, it's easier when it comes to observing it because you don't have you got the Umbra is very big compared to the moon. As you can tell tonight with it being in the Umbra for an hour and a half. Solar eclipses is very much about location because the sun only covers the moon for a matter of maybe 5 minutes. If it even covers it at all. Sometimes the moon is a little too far away from Earth and you get what we call an annular eclipse, which is where you get like a ring of sun around the moon. Yeah, the last eclipse was November 19th, 2021. And I believe we have one this year pretty much on that same day, right? Let me see, 2022. It'll be November 8th will be the next one this year. Yeah, some of you guys you're not seeing it. Neither are we. I mean, that's kind of what's happening at the moment. We're under some pretty heavy fog right now. If anyone is in a location in New England right now that is actually seeing the eclipse, shout out because I'd like to know.
Yep. Nothing
Yeah,
here.
exactly. Mara, if you're still on, how's it up your way? Heather, you're in Providence and you can see it. I'm in Providence and all I got is fog.
Very spotty clouds.
Well, let's see. What do you got over here, Derek? I'm going to switch over real quick because
Yep.
I got a little bit of at least a little red in mine. There's
All
no
right.
moon.
I got nothing.
It doesn't look like the moon. It just looks like like a glow, if anything.
Right.
Oh, hang on. I just lost the team viewer session. Yeah, it's actually gotten worse since then. Well, this is what I got now, which at the moment is nothing. Yeah, moon socket, nothing. Yeah, even Brian says it's cloudy. Can you see it up there, Brian, or is because you were on my list of places that would possibly see it during totality? Oh yeah, Heather, you probably are. So one of the options I had for tonight was to just stay home. I don't live that far from where I'm at, and where I live was actually pretty like a good location for viewing tonight. I just have a lot of trees around my house, and getting a good clear view of the sky following the path the moon would take tonight would have been difficult. Well, I just got a text from my partner who's like, hey, you should have stayed home. The moon is completely clear and beautiful here. So, thanks for rubbing that in my face. So Ken had been making jokes. Ken on the live stream. Ken's a really awesome guy, and he just made a joke about the black hole swallowing the moon. You know, since we're all on here and we're waiting for the moon to come back, that's a really interesting thing to bring up, because this past week, the Event Horizon Telescope released the first ever visual image, to an extent, visual image of the black hole at the center of the Milky Way galaxy. It's called Sagittarius A star. And it's astounding. I mean, this is the same group that took the photo of that supermassive black hole that was at the center of the Messier 87 galaxy. And this is the first time we actually have direct visual evidence that that black hole exists. And it's functioning as we expected. Thanks to Einstein. You know, Einstein's general relativity, yet again, just continues to prove itself. That black hole is quite impressive because though it is a supermassive black hole, it's about 27 million miles in diameter. It's still pretty small if you think about it. It's 26,700 light years distant from us. Looking at that would be looking at a sandwich or a plate sitting on the moon from Earth. Like, that's an amazing view. So if you haven't seen that image yet, you can Google it. You can look. You can see it on our website. You can see it on the Facebook page. We had nothing to do with the capture or the work with that image, but it is really an amazing thing to observe and to look at. Kind of mind blowing. Looks like other people are starting to see it. Not me. How you doing over there, Derek? You got anything? Your feed looks pretty dark as well. Yep.
I don't know how much you can hear in my car, but it's pretty dark. No moon here. I keep getting like a little sucker hole, and the moon will come through for about 5 seconds, and then it goes back to cloudy.
That's rather unfortunate too. I'm looking at Goes East right now, and Derek, you and I are like right on that fog line. It looks like there might be a little bit of a cooler air pushing behind. It might help out. See what that does. I'm gonna step outside for a second. If you get a good view, Derek, just boot me. There we go. There's a little bit of it there. A small image of it. So as for some of the questions that are coming up in the chat, so the moon is currently in Earth shadow fully. At 12:11 is when it's going to be in the centermost region of Earth shadow for this event. The moon won't turn black, it'll turn red. And it's because sunlight still reaches the moon. It's just not sunlight, it's not direct sunlight. It's sunlight that's coming through Earth's atmosphere and then refracting towards the moon, so it ends up shining on the moon. When it goes through Earth's atmosphere, the blue and some of the green light is stripped out of the view, and the red light is what makes it to the moon, which is why you get that deep red. Hi, Wendy. Yeah, if you're in southern New England or southern Rhode Island, good luck. I mean, I'm up in Providence and I'm getting the fog. So Ken Sebesta asked if there was anything surprising to us from the black hole picture from Sagittarius A star, the black holes in the center of the Milky Way galaxy. No, I mean, I wouldn't say surprising aside from just the awe of seeing something like that. I mean, that took a good couple hours of my day just to sit there and look at that image, and admire that we were actually able to do that. One thing that I noticed about it that I thought was pretty interesting is that disk around the shadow of the black hole, which is all that it's like plasma, but in this case, we'll just call it gas. All of that gas is kind of going around the event horizon, which is the event horizon is like the point in the black hole that light cannot escape. It's the part that looks like a hole. It looks dark. That's moving at almost the speed of light. And Sagittarius A star is only 27 million miles in diameter. So that gas ring is moving around that black hole in a matter of minutes. So to be able to capture, like looking through a lot of the individual images that were used to create that averaged image, that composite, was really astounding to see the changes in that disk of gas around the black hole over a period of like a few minutes. I think that it's moving that quickly. So I've noticed our viewer base has kind of picked up a little bit. But for those who have just come into the live stream, we're currently at two separate locations in southern New England. Derek is one of our astronomers. He's set up in like north central Connecticut. I'm set up in Providence, Rhode Island. And we're both socked in at the moment with fog. Now, I feel like at times I do periodically get through the fog a little bit. At the moment, it's pretty thick. I can see it coming into the building that I'm in. But we are optimistic that we'll get a few images of the moon periodically through the clouds. Well, through the fog. As far as I can see for this region, I really don't think we're under clouds right now. I think it's just fog. Now, we're also closely monitoring the satellite images of our area. And I think Derek is probably almost about to end up in a little bit of a clearing. And I'm not sure if that's going to quite make it to me. But if it does, we'll be able to get some more images of that really great red moon. What I may do in the time being is actually load up one of the images that we had already captured of it, and then kind of show that real quick, just for the time being, until we start getting a little bit clearer in the sky here. So this was the last image we captured of, not sure what this is doing, Paint 3D, I love that. Go Windows, I want that. Many tools here to run this, so we'll just do it with this one. This was the last moment of the eclipse right before the total eclipse began. So this was right around maybe 11:28, 11:27, this image. And you can see it as the very edge of the moon right here was still in a little bit of the penumbra. It's actually at that point. It's not in full direct light. There's just a little bit of light hitting it. And the majority of the moon is actually in Earth's shadow. And you're getting the red there. Now, I feel like tonight's moon is definitely not as red as some of the other eclipses I've seen. It could be because of the time of the year we're in right now. I mean, you figure it's springtime. So a lot of the carbon dioxide in our region is being absorbed by all the leaves and all the plants that are coming out and getting a lot of oxygen in the region. It's a little bit early in the year for wildfires, so there's not a lot of wildfire smoke coming to our region. And I don't know of any intense volcanic eruptions that are happening on Earth right now. Though I don't really follow that too closely. I feel like tonight's moon is a little bit more on the ruddy side than on that deep crimson red side. Right now would be the good time to actually take a look and tell, but it's a little too cloudy at this location at the moment to see it. Let's see here. You got a little bit of it right here. Very, very dim view. This is through the fog right now. You notice that the fog is very periodic. It's patchy. Like it's here, it's everywhere, but it comes in bouts. So it thins out at times, and at times it kind of gets really heavy. What we'll do, we'll just keep kind of moving back and forth between what we have and then what we're collecting at the moment. Now, our third team member, who was supposed to join us tonight, James, he was being very optimistic and was planning to shoot down at Frosty Drew tonight. And when he posted that to our group chat earlier, we were I thought he was joking, because Frosty Drew is we're right on the water. We've been under fog for the entire week. I figured that spot was going to be doomed tonight for a view. And that's why we canceled our on-site event earlier today. We did wait until the last minute to do it. We wanted to be sure that we were going to miss out. But it was around midday today when I started noticing that we were going to be dealing with fog issues all the way up in Providence as well. And that kind of makes Frosty Drew just not a viable place to shoot. Being that James has not joined the live stream, makes me think that he is definitely socked in. So it's now 12 after 12 or 12 after midnight, which means that we just passed maximum eclipse. So 12:11 was the point at which the moon would be in the closest point to the center of the Umbra, Earth's primary shadow, for this eclipse event. And for those who may see the eclipse in the sky right now, you probably, as Brian has just noted, Brian Kelly in the chat is one of our team members. He noted that he can see a little bit of a brightening on the very bottom of the moon. And what's happening there is the moon is not passing directly through the center of the Umbra. It's passing through the bottom of the Umbra, but well enough into the Umbra to get a good hour and a half of total eclipse. Now that we are at maximum eclipse, or just past maximum eclipse, the entire moon is going to be embedded in the Umbra, with the bottom part of the moon the closest to the edge. So it's going to appear the brightest. Now that we've passed maximum eclipse, we're going to start noticing that the western side, or the left-hand side of the moon, is going to start slowly getting brighter. There we
Still
go.
cloudy. You got more view than I do.
Well, right here we can see that bottom edge that Brian's talking about.
Yeah, the bright spot shifts from the lower right to the lower left. Sort of. Much unfortunateness. In fact, the fog is getting worse here. I can tell the clouds are getting lower.
Let's see what Goes East is saying now. I feel like they're reporting. Yeah, they're reporting a little bit of a push out of the fog in your area, but it looks like it's coming back in now. Some of that cloud deck's starting to move in now too, like you were saying.
Yep.
We'll switch back to this. This is one of the last really great images we got of the moon right before it dropped into total eclipse.
New England strikes again.
Yeah. The New England adage, really awesome celestial events plus New England plus clouds equals inseparable. Yeah.
Yes. Seems to be every single time.
I feel like overall this year it hasn't been terrible though. We've had for April was actually surprisingly good.
Yeah, we had a really nice spring.
We're typically clouded out from the beginning of March well into May. I mean, May has been a little tough this year, but April and March were pretty good.
Yep. Well. I had high hopes.
And all the forecasts I saw, it looked like right around totality, we were going to start seeing some kind of a cloud buildup, whether it be fog or low passing clouds. Looked like it was going to be an issue. I mean, even with the clouds, we still had a better than I had expected view compared to what we were looking at earlier in the week.
Oh yeah, definitely based on earlier in the week. Earlier in the week, it was like, oh, why bother? I like that picture, like that last moments.
Yeah, that's clean. You got you a little star up here.
Oh, nice.
Some stars in the field.
Now I see a halo. Is that a JPEG artifact or is that?
That's fog.
That's the fog. Okay.
Yeah, you're getting a little fog. I mean, it's fog mixed with a JPEG artifact.
Yeah, yeah, that JPEG granularity.
Right. I mean, I'm capturing all this in RAW as well.
Oh man.
So I'm going to go switch out my battery real quick. I'll be back.
Yep. little bit. No. This eclipse was probably one of the lowest eclipses as well that we'll see as far as how high the moon is off the horizon during the eclipse. It's much, much higher in the winter eclipse. I remember a couple of years ago there was a lunar eclipse in January that was almost directly overhead. Well, that's going to be it for me. It's starting to mist at my location and my telescope, and dew is fine, but my telescope and rain is not fine. So thanks everybody for coming. I hope to see you guys out at Frosty Drew at our next Friday night or other special event. Hopefully Scott will get some views before the totality period's over. And thanks for tuning in. I'll see you next time you come out.
For those who may have a clearer view of the eclipse at this moment, you'll notice that not only can you see that really great red moon in the sky, but you'll also notice you can see a lot of stars out as well. It's because during maximum eclipse or total eclipse, the moon is really very dim. It's dim enough that you would see the same level of sky as you would on a night where the moon wasn't up or above the horizon. If you're in a location where it's dark enough to see the Milky Way, you probably can see the Milky Way right now as well. Now, Derek's location, which is in largely Lisbon, Connecticut tonight, he has just informed me that he is starting to experience mist at his location, so he's starting to pack up his gear. Where I am, it's not misting yet, but it is extremely foggy. I'm going to try to push through until the end of at least total eclipse. I'd like to see if we can catch a little bit of the partial outset as well. That'll kick in at about 12:54. So we got maybe about another 20 minutes before total eclipse is over. Now, once total eclipse is over, we will lose that view of the deep red moon, because at this point we're going to start seeing the left side of the moon is going to start exiting Earth, or the Earth shadow, the Umbra. And for those that are just popping into the live stream, the image we have on the screen is one of the last good images that we captured tonight. And at a really interesting moment, it's right at the end of the partial eclipse stage as the moon was moving into Earth's umbra. And this was just before the total eclipse began. We had already had some fog over our locations at the time, but it was manageable at that point. Right now, I'm looking across the street. It looks like it looks quite eerie. All right, at the moment, it appears that we're getting some of our view back. We'll see how long this lasts, but you can see that that red moon, that ruddy moon, is starting to come back into view. Fog's probably thinning out just enough for us to catch a view of it right now. We'll see how long this lasts. The fog is, like I said, it's periodic tonight. It's kind of patchy, but if it does kind of wane back out, we might grab that last one of those two last images and put that up because these are pretty good. But you'll notice that now the bottom left side of the moon is becoming more illuminated, and that's because we're past maximum eclipse, which happened at 12:11. Maximum eclipse was when the moon was at its closest to the center of the Umbra, and now the moon is starting to move to the left side of Earth's Umbra, and will eventually be moving out of the Umbra and back into direct sunlight. All right, this image was from a little while ago. This was a couple that we captured while fog thinned out just a little bit. And in this image here, this is largely what you would be almost seeing right now if the moon was actually in view, if it wasn't for the fog at the moment. where the moon is just about to start exiting the Earth's umbra, and we're about to go back into the partial eclipse stage as the moon exits Earth's umbra. Now, the eclipse is now starting to complete because 1211 was greatest eclipse or maximum eclipse. After that, we're now starting to almost like we're backtracking what we already went through, just in reverse. You know, the moon is then beginning to move out of the umbra, and it's at 1254 when the moon will actually one part of the moon will exit the umbra. And at that point, we're back in the partial eclipse stage. And that partial eclipse stage will continue until about, looking at maybe, I think it's 155 when the partial eclipse stage will complete. And then you have the penumbral outset for about another hour, which is where the moon moves out of the penumbra. I don't often see many people stick around for that stage. Now this is again back on the live stream, and that's actually a pretty good view right there. We have the fog is kind of come and go right now. It's kind of hit or miss in a way. And that's allowing us to capture periodic views of the moon. This is a live image at the moment. So that's fantastic. Maybe we'll be lucky and all this fog will come down to the ground and the sky overhead will clear out a bit. Yeah, now we're losing it again. We'll bring up that last image though as the one to show, right? And got it right there. Now look at that though. Now we got even a little star right here coming out. So I'd say from a point of view of the eclipse, we're kind of back in action right now. Yeah, Ken, it's definitely clearing up here as well. We're starting to capture some pretty good views at this moment. I'm pretty excited about that. All right, it is now 12:54, and there it is. That bottom left edge right there, that is the very first part of the moon that is going to begin exiting the penumbra. This is the end of the total eclipse stage right now, though we will still see the red moon for a little bit. I'll keep my exposure up a little bit right now so we can still see some of the red part of the moon. But over the next couple minutes, I'm going to be lowering my exposure back down to be able to capture some detail on the left side of the moon as it comes back into the penumbral area of the moon. At my location too, the moon is just starting to become barely visible again. Kind of like it was earlier, you can see a little bit of the red area on the moon, but most of what's visible is just that little sliver of the moon that is emerging from the umbra. When you think about an eclipse, what's happening here is the moon is reached a point in its orbit around the Earth where it is on the opposite side of Earth than the sun. This is called opposition, and it is in alignment. This is also known as a full moon. And this alignment does exaggerate Earth's tides a bit. We call it the spring tide, which is what happens during the full moon. Now, when it takes the moon 27.3 days to do one full orbit around Earth. But it takes the moon 29.5 days to go from the new moon to the full moon and then back to the new moon. And the first period, 27.3 days, that's the sidereal period. And the 29.5 days is known as the synodic period. The difference between the two, which is a little bit over 2 days, comes down to the fact that during that 27.3 day orbital period that the moon has, Earth will orbit a little bit along its path around the sun. Since the phases of the moon are largely dependent on the sun, that motion that we cover over that 27.3 days changes the angle just enough to extend the lunar phase cycle, the synodic cycle, by an extra 2.2 days. Now, once when the moon goes around the Earth, the question is why, how come every 29.5 days during a full moon, we don't have an eclipse? And this comes down to the path that the moon follows as it orbits Earth. So most moons will orbit around the equator of the object that they're orbiting. In the case of Earth's moon, that doesn't do that. Earth's moon actually follows more of the plane of the solar system, and it will orbit within 5.1 degrees, either above or below, of the ecliptic. Now, the ecliptic is a path that the sun takes across the sky, and it represents the plane of the solar system. Because of this, the moon can end up either a little bit above Earth shadow, a little bit below Earth shadow, depending where it is in its orbit. Is it closer to that 5.1 degrees away from the ecliptic, or is it closer to the ecliptic itself? About twice a year, the moon will end up within a reasonable amount of degrees from the ecliptic, 1 degree, 2 degrees. And that causes the moon to actually pass into Earth's shadow, where the Earth is blocking sunlight from reaching the moon. And that's an eclipse. Now, as the course of tonight went down, we had several individuals that, and some of you got a little upset, it seemed like, that the eclipse was happening from the left side of the moon and not the right side of the moon. And you have to kind of abstract your thought a little bit here. When it comes to the moon, every day we see the moon orbiting in the sky, right? Though this orbit, this movement we see, isn't necessarily the moon's movement. When the moon moves from the eastern sky to the western sky with the stars and everything else, that's not the moon and the stars and everything that's moving. That's us that's moving. And when that happens, we call that sidereal rate or sidereal time. It's the apparent motion of the sky as it relates to Earth spinning on its axis. The moon actually orbits Earth in what we call a prograde manner, which would be orbiting in a counterclockwise motion around Earth. So in this case, the moon moves from the west to the east in the sky, but it moves very slowly because it takes 27.3 days for the moon to complete that orbit. What we see is if you were to take a look at the moon over a period of a couple hours, you would notice that it has moved just a little tiny bit in the sky against the stars. A good way to take a look at this is if you were to look at the moon tonight as it relates to the stars around it, and then remember that view or take a picture of that view. And then tomorrow night when you come outside and take a look at the sky, you'll notice that the moon is about 13 degrees eastward from that position. And the moon will orbit about 13 degrees in the sky per day. So when we look at an eclipse, the eclipse is always going to happen from the left side of the moon, not the right side of the moon. Now, of course, this is very subjective, because if you're in the southern hemisphere, us in the northern hemisphere would say if you're in the southern hemisphere, you see the moon upside down. If you're in the southern hemisphere, they would say the same thing about those in the northern hemisphere. It's an interesting concept. Up and down in space doesn't really apply. So if you were in the southern hemisphere and you're watching the eclipse, then it could appear that it would be happening from potentially the other side. Though, as far as tonight's eclipse in the northern hemisphere goes, we're going to see it pass into the Umbra. But no matter where you are on Earth, it doesn't change the orbital dynamics of the moon. I'm going to bring exposure bias down just a little bit here. I feel like we're still just a little bit too bright. Come on, you can do it. That's good. right, so even in my location, the moon has become very visible in the sky. You can actually see the red side of it with the illuminated left side coming into view right now. You know, it's interesting too, because every forecast we looked at kind of said that we were going to miss maximum eclipse or total eclipse period. And I was thinking to myself, of all parts of the eclipse to miss, that's the one you don't want to miss. How come sometimes coincidence just seems to be so perfect? Drives me crazy. Oh well. Just happy that we're getting something. Okay, so at this time, we have some clouds that have moved back into our region, but the majority of the eclipse has come to an end anyway. 1:55 was the end of the partial eclipse stage. Now the only thing left of the eclipse that would be visible would be the outset of the penumbral eclipse when the moon is exiting Earth's secondary shadow. At this point, I don't think we're going to see any more of the eclipse from this location due to clouds. And I'm quite surprised at how much we actually saw tonight, given that this entire week, the forecast was supposed to be fully overcast for tonight, largely all over the entire Northeast and New England area. Though we missed most of the total eclipse stage, which is largely the best part of the eclipse, we did get to see a lot of almost the entire eclipse up until total, a couple images during total, and then just about the entire penumbral outset we were able to see. Or not penumbral, partial eclipse outset, which is really great. Tomorrow we'll be posting some select images to our Facebook, which is Frosty Drew, it's just facebook.com/Frosty Drew Observatory. And you can also get to that from our website, which I'll post in the chat. Thanks for everybody who tuned in tonight. I'm glad we had a decent amount of live views to show you. And we'll see you out under the stars at Frosty Drew on a date pretty soon. Have a great night.